Hello my dear students, in this session we will speak about the iron oxides. Iron oxides are three types of oxides. One of them is ferrous oxide or iron 2 oxide, the other is iron 3 oxide, and the third one is magnetic iron oxide. According to the color, concerning the color, iron 2 oxide is black, magnetic iron oxide is black, iron 3 oxide or ferric oxide is red. According to some other properties, here magnetic iron oxide is characterized by its very strong magnetic property. These two oxides are not characterized by the magnetic property, but magnetic iron oxide is characterized or described by its very strong magnetic property. All these do not dissolve in water, so they are water non-dissolvable substances. They are not miscible with water. They are not liquids, but they are solids, and they do not dissolve in water in general. The color of iron 2 oxide black, the iron or magnetic iron oxide black, iron 3 oxide is red. So what is the higher oxide of them all is iron 3 oxide. This is the higher oxide. So iron 2 oxide can be oxidized into iron 3 oxide. Magnetic iron oxide can be oxidized into iron 3 oxide. Iron 3 oxide can be reduced into magnetic iron oxide or iron 2 oxide. If the temperature of the reduction process between 230 and 300, this iron 3 oxide or ferric oxide is reduced into magnetic iron oxide, which is Fe3O4. If the temperature from 400 to 700, both of these oxides, magnetic iron oxide and ferric oxide, reduced to ferrous oxide or iron 2 oxide. So ferrous oxide, magnetic oxide can be oxidized into ferric oxide. Okay, ferric oxide can be reduced into iron 2 oxide or magnetic iron oxide. If we use carbon monoxide as a reducing agent or hydrogen as a reducing agent, if the temperature from 230 to 300, so the reduction process of iron 3 oxide produces magnetic iron oxide. If the temperature is from 400 to 700, so magnetic iron oxide or ferric oxide, both of them are reduced into ferrous oxide. So if you see that from 230 to 300, and the preparation of it is magnetic iron oxide, it is very important. If you see that the temperature from 400 to 700, then the produced oxide, iron oxide, is iron 2 oxide or ferrous oxide. We will take some kinds of preparation of the three oxides and some of their properties. Let's go. Iron 2 oxide can be prepared by first the heating of oxalate, ferrous oxalate or iron 2 oxalate in the absence of air. So it forms first ferrous oxide. Here this is ferrous oxide and carbon monoxide and carbon dioxide. So why is that there is no formation of ferric oxide, Fe2O3 here? Because this carbon monoxide gas has a very strong reducing power, so it makes all the iron oxide into iron 2 oxide, the lesser of oxidation state of iron. So by heating ferrous oxalate in the absence of air, it forms or produces iron 2 oxide and carbon monoxide and carbon dioxide. Why ferric oxide is not formed here? Because of the strong reducing property of carbon monoxide, which makes all the oxide iron 2 oxide, not 3 oxide. Here we can obtain the ferrous oxide or iron 2 oxide from ferric oxide or magnetic iron oxide. How we make it? You have to remember that this temperature is very important, from 400 to 700, from 400 to 700, from 400 to 700, from 400 to 700. It produces in this temperature only ferrous oxide, iron 2 oxide. Iron 2 oxide is produced. Iron 2 oxide is produced. So don't be confused. If any of the higher oxides, like ferric oxide here, is reduced by hydrogen or reduced by carbon monoxide, and the temperature is from 400 to 700 degrees Celsius, like here and here, so the only produced substance as an oxide after reduction is ferrous oxide. Here the same magnetic iron oxide Fe3O4 plus hydrogen or carbon monoxide as reducing agents, and the temperature from 400 to 700. In this case, in both cases, ferrous oxide is formed. So two main methods of preparing ferrous oxide: from heating ferrous oxalate in the absence of air to form ferrous oxide or iron 2 oxide, or the reduction of ferric oxide by carbon monoxide or hydrogen. But the temperature here you have to memorize 400 to 700. Or to reduce the magnetic iron oxide, which is a mixed oxide, by hydrogen, and the temperature is from 4 to 700, to form ferrous oxide using whether hydrogen or carbon monoxide. So some of the physical properties of iron 2 oxide or ferrous oxide, which is this FeO, it is a black powder and it is insoluble in water. Iron 2 oxide or ferrous oxide can be oxidized in air to form ferric oxide, and the number of moles, the ratio of number of moles here, 4 to 2 ferric oxide. For ferrous oxide, molecules take 1 molecule of oxygen or 1 mole of oxygen to form 2 moles of ferric oxide. So here ferrous oxide is oxidized into ferric oxide. Okay, ferric oxide is higher in oxidation state, ferrous here is lower. So ferric can be reduced to ferrous. Iron 3 can be reduced to iron 2. Iron 2 is oxidized into iron 3 oxide. So iron 2 oxide reacts with dilute mineral acids like dilute sulfuric acid, producing iron 2 salt. In this reaction, ferrous oxide dilute sulfuric acid gives ferrous sulfate or iron 2 sulfate and water. Here we have to put into consideration that this reaction need not to raise its temperature. There is no need of heat here. It happen at room temperature. This is a very important note. Okay, ferrous oxide reacts with dilute sulfuric acid. The other oxides reacts only with conc acids. So if you see that an oxide reacts with dilute acid without heat, so it is ferrous oxide, it is iron 2 oxide. Okay, so it forms ferrous oxide or iron 2 oxide, reacts with dilute acid and acids and forms iron 2 salt, like this here, iron 2 sulfate and water. So the very important notice here is that iron 2 oxide reacts with dilute acids and with no heat. Okay, we have to notice also that if we want to memorize something which makes easy for us to balance this equation, so the number of oxygen atoms here in the molecule equals the number of the acid and the number of water molecule. Here one oxygen atom uses one molecule of sulfuric acid dilute to produce one molecule or 1 mole of water. Okay, this is the ferrous oxide. Ferric oxide or iron 3 oxide, its color is red, so it is used as a pigment. It is the higher oxides among all these oxides: ferric and magnetic iron oxide and ferrous. Ferric oxide is the higher oxide, so all the other oxides can be oxidized into ferric oxide. Ferric oxide cannot be oxidized, but it can be reduced into magnetic iron oxide or ferrous oxide. How can we prepare it? There is a lot of ways, a lot of methods to prepare iron 3 oxide. The first method, we will study it in the second unit, God willing. It is the analytical method. How we can prepare it? We take ferric oxide, it is an aqueous dissolved in water, with ammonium hydroxide, so there is exchange. Ammonium takes chloride and the iron takes hydroxide. Iron hydroxide is a reddish brown precipitate. So we take this after filtration on the filter paper and heat ferric hydroxide in a temperature higher than 200 degrees Celsius to form ferric oxide or iron 3 oxide and 3 molecules of water. Okay, here 2 iron atoms in the molecular formula of ferric oxide, so we need here 2 ferric oxide hydroxide, okay, to balance the iron number of atoms, the atoms number of iron. Okay, and here there is 3 hydroxide groups, so we have to put here 3. Okay, we have to mention that it is a very, very important note that these temperatures are very important, very important. So here above 200 degrees Celsius, in this case we understand that we heat ferric hydroxide and form ferric oxide. If the temperature is mentioned, it is higher than 200 degrees Celsius, in this case the heated substance is ferric hydroxide and the produced substance is ferric oxide. It is a very important note here. Another way, ferrous sulfate heated to form ferric oxide and sulfur dioxide and sulfur trioxide. So by ferrous sulfate or by iron 2 sulfate, by strong heating, then it forms ferric oxide or iron 3 oxide and sulfur dioxide and sulfur trioxide. The second thing is that we have explained that it is the higher oxide, so we can oxidize ferrous oxide into ferric oxide, iron 2 oxide to iron 3 oxide, and we can oxidize also magnetic iron oxide or Fe3O4 into ferric oxide. Let's have some physical properties. It is a red powder insoluble in water. It is used as a pigment, a red pigment in paints. Okay, remember that with me. Ferric oxide or iron 3 oxide and magnetic iron oxide, when they react with acids, they react only with conc acid and need heat. So conc acid means heat. Okay, ferrous oxide or iron 2 oxide reacts with dilute acids and do not need heat. Okay, so the other higher oxides, which is ferric oxide here or iron 3 oxide or magnetic iron oxide, this, if they react with acids, they react with acids, conc acids only, not dilute, and the reaction need heat, so it is not at room temperature. So something to help us to balance this equation is 3 atoms here of oxygen, and this number is the number of sulfuric acid concentrated and the number of water molecules. So here ferric oxide produces ferric sulfate. So when ferric oxide reacts with conc or concentrated acids with heat, it is important, heat, okay, they forms iron 3 salt or iron 3 sulfate in this case, and the number of oxygen atoms here is the number of acid and the number of water moles. Okay, let's have the third one. The third one is a mixture between ferrous and ferric. So let's have a summation. Here in ferrous 1 iron and in ferric 2 iron atoms. So here 3, the summation, 1 oxygen atom and 3, this is 4. So it is a mixture between iron 2 and iron 3 oxides. So it is called, this magnetic iron oxide, ferrusoferric. Ferruso means there is a ferrous in its composition, and ferric, there is ferric in its composition. So magnetic iron oxide is a mixed oxide, and there is a question upon this point. We'll discuss it this time. Okay, preparation of magnetic iron oxide. If you remember with me that the reaction or the action of hot air on iron, and the reaction of hot water vapor on iron, elemental iron, if the iron is red hot or the temperature reaches 500 degrees Celsius, it forms magnetic iron oxide. So the effect of air or the effect of water vapor on elemental iron, in both cases they form magnetic iron oxide. Or you can consider it as two methods of preparation of magnetic iron oxide: to heat the iron until redness, or until it get red, or to heat it to 500 degrees Celsius and react it with oxygen of air or with water vapor to form, in both cases, magnetic iron oxide. So the effect of water vapor, the effect of air by raising the temperature to 500 degrees Celsius to the iron, element iron, okay, will produces only one oxide, which is magnetic iron oxide in both cases. Okay, this is the first way to prepare magnetic iron oxide. We know that the ferric oxide is the higher oxide, so we can produce the other oxides by its reduction. So if we reduce ferric oxide by carbon monoxide or hydrogen as a reducing agents, it will form magnetic iron oxide or ferrous oxide. What is the difference between the two conditions? Here, the temperature. If the temperature is from 230 to 300, in this case the reduction of ferric will produce magnetic iron oxide. So magnetic iron oxide is the product of the reduction of higher oxide, which is ferric or iron 3 oxide, by using carbon monoxide or hydrogen. But the temperature here, you have to memorize it, 230 to 300. So it forms ferric or magnetic iron oxide. Okay, the properties of magnetic iron oxide: it is a black powder insoluble in water. It has a strong magnetic property. It has very strong magnetic property. Okay, this is the only oxide which has magnetic. The only oxide which has magnetic property is magnetite or mixed oxide, or Fe3O4. It is magnetic iron oxide, and it is the only oxide from the three kinds of oxide, ferrous and ferric and magnetic iron oxide, which contain or which is characterized by the by having magnetic property. So magnetic iron oxide can react with acids, but here we have to notice that it can react with acids, but in this case it reacts with acids, conc acids, like ferric. So conc acids needs heat. So magnetic iron oxide reacts with sulfuric acid liquid, as it is conc or concentrated, forms two kinds of salts: ferrous or iron 2 sulfate and ferric iron 3 sulfate. So it forms a mixed salts that prove that the magnetic iron oxide is a mixture between ferrous and ferric, iron 2 and iron 3. As it when it reacts with conc acids, it forms iron 2 salt and iron 3 salt. So here we want to make some balance. Here there is 4 oxygen atoms here, and the same is the number of moles of acid and the number of moles of water. It is 4 here, Fe3O4, the magnetic iron oxide, and the same here, 4 moles of sulfuric acid, and produces 4 moles of water. So here we have to know that this magnetic iron oxide is, in the first place, it is a mixed oxide. So when it reacts with conc acids only, this oxide cannot react with dilute acids. Okay, it reacts with conc acid and with heat. It forms two kinds of salts: iron 2 sulfate and iron 3 sulfate. Okay, magnetic iron oxide is oxidized into red oxide or ferric oxide. We can prepare magnetic iron oxide by the reduction of ferric oxide, and the heat is from 230 to 300. Here's the opposite operation, or the opposite reaction. We can prepare, or we can this magnetic iron oxide undergoes oxidation by oxygen, and by heat each 2 molecules or 2 moles of magnetic iron oxide produces 3 of ferric oxide by oxidation. Ferric oxide can be reduced to magnetic iron oxide, and magnetic iron oxide can be oxidized to ferric oxide. So here magnetic iron oxide can be reduced to ferrous or iron 2 oxide. How can we make this? We have to memorize that from 400 to 700 we can reduce either ferric oxide or magnetic iron oxide, both of them, by using one of the reducing agents like hydrogen or carbon monoxide. And as the temperature here is from 400 to 700, so all oxides will produce ferrous oxide. Okay, so the reaction here we reduce is the reduction of magnetic iron oxide by using hydrogen as a reducing agent or carbon monoxide as a reducing agent. But here you have to know that the temperature is from 400 to 700, and in both cases, and it produces only ferrous oxide or iron 2 oxide. So iron 2 oxide is related to this temperature, which is from 400 to 700 degrees Celsius. Okay, so when you see that 400 to 700, you will put in mind that the produced oxide is ferrous oxide or iron 2 oxide. Okay, here is a very important diagram to understand what happens in all these oxides. Okay, first thing is that the oxidation by heating iron to 500 degrees Celsius by air, using oxygen of air, or using water vapor. In both cases it produces magnetic iron oxide, Fe3O4, which is a mixture between iron 2 and iron 3. So oxides like magnetic iron oxide, Fe3O4, or ferric oxide, Fe2O3, can be reduced by using one of the reducing agents like hydrogen. Okay, and the temperature to obtain ferrous oxide in both cases, reduction of magnetic iron oxide and reduction of ferric oxide. When the temperature is from 400 to 700, they produce by reduction ferrous oxide or iron 2 oxide. Okay, we can reduce here ferric into magnetic iron oxide, not ferrous oxide. But here the temperature is different. We can reduce the ferric oxide into magnetic iron oxide, but the temperature from 230 to 300 degrees Celsius. So this 230 to 300 Celsius is related to producing magnetic iron oxide from ferric oxide. Okay, here from 400 to 700 is related to the ferrous oxide. So both cases, or both the oxides, magnetic iron oxide and ferric oxide, can produce ferrous oxide, but the temperature here is from 400 to 700 and from 400 to 700. If we want to reduce the ferric oxide or the hematite into elemental iron, we have to use one of the reducing agents like carbon monoxide and raise the temperature higher than 700 degrees Celsius. So if the temperature is higher than 700 degrees Celsius, then the produced substance is elemental iron. So elemental iron produced by reduction of ferric oxide by using one of the reducing agents like carbon monoxide or hydrogen, and the temperature is higher than 700 degrees Celsius. There is a very important note here: from 400 to 700 related to ferrous or iron 2 oxide, from 230 to 300 it is related to the production of magnetic iron oxide, and here higher than 700 related to the production of iron by the reduction of ferric oxide. I hope that everything is clear for you now. We have to answer some questions. The following equation represents the oxidation reaction of the substance X here to form a substance Y. So Y here is X3, as it is a balanced equation, X3 and O4. X3O4, the substance is magnetic iron oxide. What is the substance? This X is iron. Okay, this X is just element, and this is the compound. This is magnetic iron oxide. So it is not ferric oxide, not ferric oxide, not ferric oxide. Fortunately, this is the correct one. And here it is elemental iron with oxygen heated to 500 degrees Celsius or until it is red by heating. Then it forms magnetic iron oxide. Iron forms by oxidation at 500 degrees Celsius magnetic iron oxide Fe3O4, and this is the correct answer. Here is another example. The mass of each of the following decreases by heating except. So all that substances which are by heating decreases, we do not want this. We want the substance which is constant or increase by heating. Okay, so heating iron to oxidate in the absence of air or in air, no problem. It will lose carbon monoxide and carbon dioxide, so it will decrease. So it is we do not want this choice. Heating iron to carbonate strongly, it releases carbon dioxide and only ferrous oxide remains. So it loses carbon dioxide like the other carbon monoxide and carbon dioxide. So it decreases also. Heating iron till redness in the air will make iron transformed into magnetic iron oxide, so the mass of iron increase. So this is the correct answer. The mass of iron will increase. All the following are methods of preparing red iron. Red iron here, ferric oxide Fe2O3, except these are the methods of preparation of ferric oxide or iron 3 oxide or red oxide. Okay, red oxide or iron 3 oxide or ferric oxide, all these are the same compound, Fe2O3. So all these methods of preparation, but except here. So the one who is not a method of preparation that we want to collect or want to choose. Okay, oxidizing black iron oxide. Whether black iron oxide, it is magnetic iron oxide or ferrous oxide, oxidizing these substances will produce the higher oxidation state of iron, which is red iron oxide or ferric oxide. So this is a wave preparation. The reaction of red hot iron with air. The reaction of red hot iron with air or with water vapor at 500 degrees Celsius till red, the iron is red, it forms magnetic iron oxide Fe3O4. So it is not the way to prepare the red iron oxide, which is Fe2O3. This is not a method to prepare ferric oxide. So it is the answer here. What are the number of moles of each of iron, oxygen, and hot concentrated sulfuric acid? To prepare 2 moles of iron 3 sulfate. Iron 3 sulfate refers to the reaction of iron or ferric oxide, not a mixed oxide. It is a ferric oxide, not a ferrous oxide, because it only forms iron 3 sulfate. Iron 3 sulfate is a product of reaction between ferric oxide Fe2O3 and conc sulfuric acid with heat. So 1 mole Fe2O3 produces 1 mole of ferric oxide Fe2O3 produces ferric sulfate Fe2. 1 mole produces 1 mole. Okay, so how many number of moles of iron 2 or iron moles, number of oxygen inside? Oxygen in 1 mole 3 atoms, Fe2O3, and iron here is 2. Okay, but here we want to prepare 2 moles of iron 3 sulfate. So number of moles of iron must be not 2 Fe2O3, but we have to multiply the whole equation by 2. So it is 4 and 4. It is not 6, it is not 3. So here the oxygen number of moles is 3, but here we want 2 moles, so it have to multiply to 6 atoms. So here the number of oxygen moles. Oxygen is a diatomic molecule, so it is 6 atoms or 3 moles. 3 moles here, 3 moles of oxygen 2. And number of conc sulfuric acid. If we memorize with each other that the number of sulfuric acid conc equals the number of oxygen inside the ferric oxide. Ferric oxide contains 3 oxygen, so the balanced equation is supposed to have 3 moles of sulfuric acid, but here we want 2 moles of iron 3 sulfate. So we have to multiply this 3 by 2 equals 6. Here is the equations. The equation: ferric oxide 3 sulfuric acid, conc and heat. Notice that you have to memorize this: conc and heat, then ferric sulfate and 3 molecules of water. So the number of iron, if you multiply this by 2, then it is 4 moles of iron and 3 moles of oxygen O2 as it is multiplied by 2, and 6 moles of sulfuric. Okay, let's have another example. Which of the following equations is iron referred to by M? Look, we have to see equations here, and we have to contemplate on each equation individually and see if this M is iron or not. Here in the first equation, copper replaces M and forms copper sulfate. If M is iron, copper cannot replace it. Okay, iron is more active than copper, so this cannot happen. Iron can replace copper in its salts, but copper cannot replace iron in its salts. Okay, so this is not correct. M sulfate forms MO and sulfur trioxide. We know that iron 2 sulfate is from the methods of preparation of ferric sulfate. 2 moles of iron 2 sulfate strongly heated to form sulfur dioxide, sulfur trioxide, and ferric oxide. So here 1 mole is not correct, and this is not the products. Okay, 2 sulfate and 2 sulfate. Okay, it forms ferric oxide, Fe2O3, sulfur dioxide, and sulfur trioxide, and this is the correct answer. Okay, let's have another example. A mixture of iron 2 chloride and iron 3 chloride can be prepared by the following methods. Iron 2 and iron 3 as a mixture is prepared by magnetic iron oxide. Magnetic iron oxide is first prepared by passing water vapor on red hot iron, then adding hot HCl. When we pass water vapor on red hot iron, it forms magnetic iron oxide, which is a mixed oxide, and then the reaction with conc HCl will produce both salts. We want here the exception, so it is not the choice that we want. Passing chlorine gas on red hot iron, chlorine is an oxidizing agent. It will produce only iron 3 oxide. It will not produce iron 2 oxide. So this is the correct answer. Here, heating iron 2 sulfate and treat the solid product by with carbon monoxide. Heating iron 2 sulfate is the way to prepare ferric oxide. Okay, so this is ferric oxide, iron 3 oxide, solid, and treat it by carbon monoxide as a reducing agent, and the temperature, it is very important, from 230 to 300 to form magnetic iron oxide. Magnetic iron oxide is a mixed oxide adding conc HCl, so it will produce a mixture of iron 3 and iron 2 chloride. Okay, so the correct answer here is B. Heating a mixture of iron 3 and iron 2 hydroxide with concentrated hydrochloric acid. Heating a mixture, so D is not correct, and the correct answer here, heating the mixture of both iron hydroxide, iron 3 hydroxide and iron 2 hydroxide with a conc hydrochloric acid will not produce iron 2 and iron 3. So the correct answer here is passing chlorine gas on red hot iron, as chlorine gas is an oxidizing agent. It can produce only iron 3 iron 3 chloride. It cannot be a method to prepare the mixed oxide. Here, heating a mixture of iron 3 and iron 2 will produce and then reaction with conc hydrochloric acid, it will produce also the iron 2 and iron 3 chloride. Here the only method which cannot produce a mixed oxide or iron 2 and iron 3 is passing chlorine gas on red hot iron to form only ferric chloride. It cannot be used to make iron 2 chloride. So the correct here, is B. Heating a mixture of 2 and 3 iron hydroxide will produce both of them, so it is excluded. Another example, heating iron to oxalate in the absence of air and then treating the produced solid with dilute sulfuric acids yields, this is iron 2 oxalate. Iron 2 oxalate forms in the absence of air, forms ferrous oxide, FeO, iron 2 oxide. Iron 2 oxide can produce only with dilute acids iron 2 sulfate. So this is the correct answer here. It will not produce iron 3. It will not produce iron 3. So these both are not correct. Okay. Iron 2 oxide and carbon dioxide and carbon monoxide. There is no in sulfuric acid or in the oxide any of the carbon dioxide or carbon dioxide monoxide or carbon dioxide or the source of carbon in it. Okay. So here oxalate oxalate is heated in the absence of air. It forms ferrous oxide and carbon monoxide and carbon dioxide. So we ask about the solid, not the carbon dioxide and carbon monoxide. We ask about the solid itself, ferrous oxide. When it reacts with a dilute sulfuric acid, it only form iron 2 sulfate. Okay. Let's have another example. What happens when carbon monoxide gas is used in reducing solid compound produced by the strong heating of iron 2 sulfate? Iron 2 sulfate, when it is heated, 2 moles of iron 2 sulfate will produce ferric oxide. Ferric oxide, yes. Well, the question is, what happens when carbon monoxide gas is used to reduce solid compound, which is ferric oxide or iron 3 oxide, produced by the strong heating of sulfate? Okay. So ferric oxide will be reduced in a certain in a certain condition, will be reduced into magnetic iron oxide or ferrous oxide. If it is reduced in a temperature from 400 to 700, it produces ferrous oxide or iron 2 oxide. If it reduced in a temperature from 230 to 300, it will produce magnetic iron oxide. And in both cases there is a carbon dioxide. It is not a group of gases, it is only one gas, it is carbon monoxide, and this is the correct answer. Okay, which turns clear lime water turbid. Here another example. When iron oxide X loses some of its oxygen, oxide Y is formed, which in turn loses some of its oxygen at a temperature higher than 400 degrees Celsius, means from 400 to 700, and forming oxide Z. From 400 or higher than 400 to 700, it forms ferrous oxide, FeO. So this Z is ferrous oxide. So it is not red iron oxide or ferric, it is not magnetic iron oxide, which is Fe3O4. It is ferrous oxide. So in the presence of a reducing agent, which of the following identifies XYZ? X reduced into Y and Y reduced into Z. The higher oxidation state of oxides is ferric oxide or red iron oxide. So it is not magnetic oxide, it is not ferrous oxide. It may be ferric oxide and it may be red iron oxide, which is the ferric oxide also. But this is wrong here, so this is the correct answer. Red iron oxide reduced into magnetic iron oxide in the temperature from 230 to 300. Both of them are reduced into ferrous oxide in a temperature from 400 to 700, and this is the correct answer. Let's have the last example here in the unit of transition metals. Which of the following describes 1, 2, 3 and in this Venn diagram? So 1 here is the area of iron 3 oxide or red iron oxide. This area 3 is magnetic iron oxide, and the common area here is something in the properties of red iron oxide and magnetic iron oxide in the same time. So ferric oxide here is 1. This means it is a property of ferric oxide, not magnetic iron oxide. Ferric oxide reacts with acid, forming 2 types of salts. No, it is wrong. The only one which form 2 types of salt is magnetic iron oxide, not ferric oxide. So this is wrong. B, 1 here, the property of ferric oxide can be obtained from iron 3 hydroxide. Iron 3 hydroxide, when heated above 200 degrees Celsius, it will form ferric oxide. Okay, so 2 here is a common place between magnetic iron oxide and ferric oxide. So this property must be a character from a character of both oxides. So here 2 can be reduced to ferrous oxide. Yes, both of them, ferric oxide and magnetic iron oxide, both of them here can be reduced to ferrous oxide when we use a reducing agent like hydrogen or carbon monoxide in a temperature from 400 to 700. So this also correct. Reacts with conc acids, forming two types. This 3 is a character only of magnetic iron oxide, and it can react only with acids, with conc acids and heating, okay, and forms two types of salts. Here, if ferric oxide reacts with acid, it only form ferric acid or ferric salts or iron 3 salts. So here 3 refers to a character of magnetic iron oxide which forms two kinds of salts by reaction with conc acids. So this is the correct answer. God willing, in the next session we'll speak with each other about chemical analysis. Good night to you all. Thanks.